Welcome to Atmosoft Tech Talks, a live show where we discuss everything you need to know about software development and technology in business. I'm Natasha, your host, and joining me today is our COO, Bill, a solutions architect at Atmosoft. Hi, Bill. Thank you for joining us today.
Thank you for having me.
Yeah, let's dive right in, Bill. One of the biggest topics in our industry is secure coding. Can you explain why it's so important?
So security is kind of critical to a lot of things that we do in development. In the aspect of that, there's kind of two pieces from the development side of security, and that's going to be one is authentication, and that's who you are. So who are you? And authentication can be you can go through a third party for that. A lot of products will use like Microsoft Azure AD. Google has authentication. Twitter has authentication support. Facebook has authentication support. And when you tie in with one of those providers, what you're saying is, I trust Facebook to authenticate and tell me that this is Natasha. So that's kind of the first layer of security is who are you? And then after that, you have the second piece, which is authorization. Now, authorization is what can I do? So we've already established who you are. You're Natasha Moore, and maybe we got that information from Facebook. Maybe we got it from Google. Maybe we have our own custom authentication provider that we're using, and then we go and we look up and we say what can Tasha do within our application space. Maybe you're an admin, maybe you're a standard user, maybe you're allowed to run reports, maybe you're only allowed to create invoice line items. Maybe you're a system admin, so you can add users to the system, you can remove users and that kind of stuff. So it's a broad context, and that's generally the context we're looking at in development. Is we don't often want every user to have every feature in the application, and we also need a good way to tell us who a user is. So going back to authentication, we can talk about the types of authentication. Most of the stuff that the majority of people are familiar with is username, password into a website, username, password to log into Windows, username, password to log into Linux. There's other flavors of authentication which are becoming more popular, like MFA, which is multi-factor authentication. And what that means is I'm going to you're going to still log in, username, password, but then I'm going to ask you for an additional set of information on something that should be owned by you. That could be something called a YubiKey. YubiKey is a type, but they're the little USB devices that you plug into your computer. You can authenticate that way. Another way is those RSA keys that are generating random 6 digits every little bit. Most people these days are using, I'm going to send a text to your cell phone, or I'm going to send a number to your email. And so that's just a way to add some more security around allowing users into the applications. If your username and password is compromised, it becomes even less likely that the person's going to have access to your phone as well, or hopefully not your email. And so we add a little bit of layer of security there. So that's security, and that's what we're trying to do. We're trying to control who or know who and control what. Yeah, something you know and something you are. Yeah, great comment, Brett. Thank you. Yeah, something you know and then something you are. And so that's actually a really great way to explain it. So we're trying to control who and then what they can do in a particular system. And where we run into security vulnerabilities is when in our coding practices we don't take into consideration, some users aren't going to type in what they're supposed to type in particular boxes. Maybe our application is being hit with Postman instead of a browser, and we're changing up parameters and we're passing different data. Messing around with the URL. A lot of websites you'll see, you'll have the main URL like www.atmosoft.com/user/1/order/1. And when you see those type of URLs, you kind of know that things are going on sequentially in the back end. So that's one security practice I would push right now is if it's being displayed in a query string, you should probably be using GUIDs or a random number generator to get larger number sets, so it's not easy to guess what your order numbers are, what your user IDs are, that kind of thing. So that's kind of overview of security from a development perspective.
Okay, fantastic. That makes sense. What would you say are some of the most common mistakes developers make when it comes to securing code?
So I stated earlier, last second, one of the biggest areas of mistakes is not sanitizing your input. We have a particular attack that it's not as common as it was because I think a lot of the vendors started doing better work on the back end and in the frameworks to prevent these types of attacks. One of them is a SQL injection attack. If I'm pulling data, say from the query string, or I'm pulling data from a form, and then I'm running against like a non-parameterized query, or I'm not using a stored procedure, which are good security practices, by the way. If you're querying SQL Server and I have a stored procedure, and a user passes in some bad input, that's not going to get combined into the code and then executed like an actual SQL statement. I typically try to avoid inline SQL kind of at all costs because that can lead to the SQL injection attack. But again, what that is basically I'm passing in some input that we weren't expecting in our username field that can cause the database to do weird things like return a list of users, or grant admin access, or open up an XP command shell. If those sorts of things are available, those can be done via SQL injection attacks very quickly. So that's a good way to get your data leaked out all over the place. So sorry, validation or sanitizing user input.
Mhm.
Let's see. So sanitizing user input is a problem. And then crap, lost my notes. All right. So sorry, I had my notes and I cannot find them. So
You're good.
so we have sanitizing user inputs. We have basically validating routes on your website, making sure that you're authenticating your users correctly, and then not allowing users to kind of get elevated permissions in the application by doing kind of unexpected. The biggest thing is I think typically when we're coding, we're thinking about the normal path, like, okay, username, password, login, username, invalid password, login. So we're taking about all these paths. But a lot of times, and it can get super complicated if you're working with code, and you got to be like, oh, what if they try to inject a script tag into this username field, and then handling that and sanitizing it. Fortunately, there's a lot of libraries that'll sanitize the data for you that do a fairly good job. So it's not a big lift to go ahead and use one of those libraries to make sure that the input that you get from the user, basically any input you get from the user, should be validated to make sure it's what you're looking for.
Yeah. Also, isn't there I feel like that you kind of touched on this, but isn't there also, like, the principle of least
Oh, principle of
privilege?
least privilege. Yes.
Yeah.
So what that is principle of least privilege is my application should only run with the level of permission it needs to do its job. So a lot of times back in the day, there wasn't the best security practice, but it was common. Everyone was doing it, including me, until we learned that this was not a great idea. You would just set up your web application. So on Windows, you'll have a web server, and then in that web server, you'll have an application pool, and that application pool is given an identity. And so we would deploy our code. It would be just using the default identity, and then all of a sudden we run into this problem where couldn't access a particular file somewhere on the file system. So immediately you're like, let's just get the app pool admin rights, which is not something you should do anymore. We've learned better. Don't ever do this. And then all of a sudden, all your security problems go away. Problem with that is that if a user comes in and your application is running with the elevated privileges and they're able to compromise your web server, now their process or their activities they're doing are also running with elevated privileges. So you have access to all the file systems, you have access to the network maybe, and it can lead to a big compromise. So the idea of least privilege is I'm going to give my code. I start this way, right? I'm going to give my code just the bare minimum, and then I'm going to run my app. I'm going to test it. I'm going to see how it does. If I don't have any problems, I'm going to leave it there. If I need a particular permission, let's just say I want to create some logs, and I want them to go into the temp directory, so I can log in production. And by default, the application pool identity does not have access to temp directory. I believe that's true. So so if I go try to write a file there, I'm going to get an error. I'm basically the operating system going to say you're not allowed to do that, which is good. But if I have to, if there's a requirement, or if that's absolutely where I want to put it, typically the way I would solve this problem is I would just add the logs into the web server and make them non-browsable. So that way the logs are all kept there, and you don't have to worry about assigning permissions to a user outside of that.
Mm-hmm.
But in this case, we want to write to temp. That's where all of our other log files are going. So we were going to create a new directory in the temp the temp directory, and we're gonna log out there. And so I would then just give the application pool identity permissions to write and read from that directory. And again, on writing and reading, those are two separate permissions.
Yep.
So actually, if my application didn't need to read those files later, then I would just give it write access. So then it wouldn't be able to read anything from that directory. And so what I'm doing there is I'm deploying my application, and you don't always have to deploy it. You can do this locally too by making sure that you're running Visual Studio as a non-administrative user. That will help you catch some of these in your development lifecycle. So I never run Visual Studio as admin.
Okay.
Unless I'm being explicit about it. So
Mm-hmm.
I'm going to start Visual Studio, and I know I want it to be able to do some admin type functions. So I'm going to right click on the desktop, and I'm going to run as administrator.
Mm-hmm.
And then I'm going to run. But other than that, Visual Studio is running least privileged because I just don't, it's just better that way. You'll see the errors in your code. I can't write here. I can't read here. You might catch those a little bit earlier. But when you get into production, you're probably most likely going to run into scenarios like that as well. And then you just need to adjust the permissions as you're going through there. Another way to do it is to create we use PowerShell and task scheduler to automate some of the work that we don't need to be doing every day, and it's just repetitive tasks, and so we just script them out with PowerShell, and
Yep.
then we run them in the task scheduler. So for those scenarios, I'll create a special user, because one of the other things you don't want to do is Bill Moore of Atmosoft goes into his company and he's working on the servers, and all of the scripts are assigned to Bill Moore with Bill Moore's user permissions, and then Bill Moore leaves and we disable his account, and then now nothing is working. And so you have to go in and troubleshoot all that and reset up all the permissions and change it to another user. So typically what I recommend in that particular case is you just create a user, give it a standard set of permissions, adjust its permissions as you need, and then that's the user that your application pool is running under, and that's the user that your scripts are running under. And then it kind of saves you the headache later of when people leave the organization and their accounts begin to get disabled, and then all of a sudden you don't have your data transfers happening, or different activities that you have automated all of a sudden stop working.
Yeah. Okay. Those are great tips, Bill. Now let's say you have a piece of code. How would you go about securing it?
Okay, so first thing I'm going to look at is what is coming in to.
Mm-hmm.
Okay, let's say in this particular example, we'll just use a function. So
Okay.
we have a function and we have some parameters. I'm going to take a look at those parameters, and I'm going to think about, okay, where does that input come from, right? Is it coming from another function that's calling it? In that case, where's that data coming from that function? Is it reading something from the database? Okay, and I'm going to kind of backtrack because I want to be clear and try to catch some of my edge cases. I think to me it makes sense at the function level. So we want, then that's the sanitize input step, right? There are some things where you don't need to sanitize. If I'm looking up essentially a read-only value from a database, or a table that is maintained only internally, that is used, the values are read, basically read-only on the application side, then those type of inputs you don't need to scrutinize as much. It's when you're collecting input from a screen, from an application, from a phone, and the user's typing it in. They kind of have some free form activities,
Yeah.
and you even should be validating that if I have a slider on a web page, or if I have, an up down control and they're not allowed to type into it, that doesn't mean that they don't go in back behind the scenes, modify the HTML, and then pass you an unexpected value. And so
Yep.
you want to sanitize all your inputs going into your function. So I usually do that at the top. I usually call it my validation step. So when I'm writing code, I'll do a comment. I'll say validation, and then I'll specify all the things that I'm expecting to be true, and then I'll also do my sanitation where I'm actually checking to make sure values are within expected range. That gets complicated, and you can adjust your level of comfort based on how much work you want to do. I mean, if you're an organization that has had a security breach in the past, I think they're going to be more sensitive to that, and so I think they're going to want better sanitation in that particular area of the variables coming in. So basically, anything that's coming in external from the system, from a user perspective, maybe not necessarily so much from the internal team's perspective. You want to make sure all that data is kind of sanitized and cleaned up. And then in the higher level languages, and when I say higher level languages, I'm talking languages like Python, JavaScript, C Sharp, Java. They're all kind of getting. It's not impossible, but you very rarely get buffer overflows in those languages. I'm sure it can be done, but usually the runtime is kind of managing that and keeping a look at everything and doesn't let you overwrite your buffers. When you get down to lower level languages like C, C++, and assembly, you can, they call it shooting yourself in the foot. You can shoot yourself in the foot by, I'm going to create a buffer and I'm expecting 255 characters. And I created a 255 character buffer. And then I'm reading into that buffer and they sent me, 5,000 character string, 5,000 character length string. And I'm reading in, and then all of a sudden, and C++ isn't going to say anything. It's just going to keep writing in memory for 5,000. So you're not like, you're 45,000 characters, you're 4,500 characters outside of what it was expecting, and you're just overwriting sequential memory, and that can lead to buffer overflow. So in C++ and C in assembly, you got to be a little bit more careful. You don't really have those problems in .NET, so you don't have to watch for those as much. I mean, you still want to take it into consideration that it's a possibility, but it's not something you often have to be concerned about. And then I'm going to look at the structure of the function or the structure of the class or the structure of the code and make sure that I'm not doing anything unexpected. Like, for example, let's just say I'm doing an operation against a database that can fail. In .NET, there's when we're working with collections or we're querying the database and we're using Entity Framework, we have there's a first method that you can do that will just give you the first record from the list. Now, if the list is empty, it throws an exception. It's gonna be is it a null reference? Yeah, I think it's a null reference exception. And so, but then there's another one you can use called first or default, which just returns null but doesn't throw an error. So you want to be looking for things like those, because when your application, when an error occurs in .NET and your application doesn't explicitly catch that error bubbles up. And then you basically have an application leak on your web page. If you don't have the website set up to handle that situation correctly, you'll see a page and it's a debug page. And that debug page will have, 10, 20 lines of your code, show you where the error is. People can see the parameters, they can see your call stack. And all that information is information that if I was an attacker, I could use to further an exploit into your application, because I'm starting to get an idea of what's going on. Okay, if I pass this type of data, the page throws an error. I know I'm working in this auto invoice library, and I'm about 2,000 lines into the file. I'm in this particular function, so I can kind of start to get an idea of what's going on the code and other better ways to break it. So you want to be careful about leaking the error information in your pages. So that's the other thing you want to check for is if I have error handling is expensive, and you don't do error handling in every case. There's some cases where you kind of just don't care. And that's okay. That's fine. That's application architecture decision you and your team can make. And It's however you want to do it, but you do have to be careful about leaking that data to external people about exactly what's going on inside of the application.
Yeah, one of the tips that I saw when I was doing research for some of our short form videos that I post on our page, if you guys aren't following on LinkedIn, it's at Masoft, was that one of the things you need to make sure that you're careful of is not letting the error codes give away too much information.
Yeah, yep,
And that's why you have like error pages that you specifically designed where it maybe just gives the number, but not all that information that they
sure,
don't need
sure, yep,
because
yep.
they can either use that against you or it'll just confuse the
Yeah, yeah,
end user.
yeah. The user would be like, "What the heck is going on?"
Yeah.
ASP.NET Web Forms is kind of famous for that. You got that yellow orange
Yep.
compilation error page that you get
Yep.
that kind of shows you all the code and all the code around it, and you're like, that's actually turned off by default
Yeah.
when you deploy or when you deploy a non-debug build, but which is nice. Like, and then a lot of companies are moving to a more of an opt-in versus explicitly turning on. So I'll have these lists of security features that are provided by my framework, and you're automatically opted in unless you explicitly say no. Don't do the buffer overflow checks. I don't need
Yeah.
you to do those. I got that all handled myself, and so then you can opt out. But I like the opt-in strategy better, and then most people just use the default configuration, which out of the box is going to be pretty secure. Well, as secure as
Mhm.
they can as they can make it,
Mhm.
and then they can turn off the security features if they're willing to take that risk, which I don't recommend. Most of the time, if you're having to bypass a particular security feature, you really need to think about what you're doing and why you're doing that. I can see in some instances, but I feel like those cases should be rare,
Yeah.
where I need to turn off buffer overflow checks because I just have to have that 10 millisecond, 10 nanosecond real-time system communication. I can't afford to have that 10. If I'm working on like a life-saving device, maybe that 10 nanoseconds is critical in getting information out, and I just don't want to do it there. But in most cases, I usually leave all the security features turned on for a given framework, or IIS, or some server configuration.
Yeah. Better safer than like not safe.
Yeah.
A data breach or
Yeah, I
something.
think there's versions of Windows where it doesn't even really have Windows in it. It's basically it's a Windows Server version. I haven't used it a ton of times, but basically it just runs and it's all the services and everything, but there's no GUI, no desktop, nothing. Like you
Interesting.
basically you basically command line into it and set up all your stuff, and and then yeah, there's no
That's
GUI, so you
crazy.
don't have any of those Windows vulnerabilities there because it's just basically all just running in the background. It's like, I don't need to worry about you're on this. No one's going to look at it anyway.
Yeah, yeah. Well, thanks, Bill. That was really informative. We are almost out of time. Do you have any final thoughts or key takeaways you want to give to our listeners?
Yeah, I think especially the impetus for this series of videos was last week. I had about $450 of unapproved transactions run through my business account. I have not figured out where that leak occurred yet. That same week, I got an email from my son's dentist saying that his system had been breached and my son's dental information had possibly been compromised, and the DMV for both Oregon and Louisiana in the same week, all of their records were taken.
Oh my
So
gosh.
if you are in Louisiana or Oregon, you may want to check with your DMV. That
Yeah.
is super important information. Your driver's license, your birthday. I'm
Yeah.
assuming Social Security number is tied to it in some way. It's not on my card, but I'm
Yeah.
assuming they probably have it in there somewhere. And so you should check and make sure that your information didn't get compromised. And being that, I think I don't think there's any way to get 100% security coverage, but I think we can do a lot better by thinking about security when we're creating our code, and then making sure that we're at least doing the basics, like the sanitation and validation of our inputs, and we're running with least privilege in case the application does end up getting compromised. It becomes significantly more difficult to compromise the whole server. So I think taking a look at those, understanding security, understanding what you're looking at, understanding how to write secure code is a great way to both improve your marketability and make sure that you're not one of the unfortunate developers who had an application that got compromised. And sometimes it's not the developer's fault, right? Sometimes
Yeah.
sometimes the system gets compromised, and that's not really the developer's fault. But I mean, we do have to deal with those scenarios too. So you kind of got security coming at you from all sides, and I think the hacking space is getting more,
Better.
yeah, more turbulent for sure. Like
Yeah.
you're seeing a lot more bubbling up in the news, and there seems to be so many coming out that they're kind of stopping covering it. and
Yeah.
and I think we all just need to take security a little bit more seriously and make sure we're protecting our data. Oh, one other thing I would like to recommend too: encrypt your data at rest. Like if you're storing PPI, or sorry, PII, personally identifiable information, first names, last names, phone numbers, addresses, credit card numbers, and anything, social security numbers, especially in the medical field. If your data is in a database, it should be encrypted, and those keys should be basically guarded with like Fort Knox
Yeah.
to get into that data. I think that's really serious, and I think people need to take that into consideration. If I'm storing someone else, if someone's giving me the trust to have their personal information in my system, I at least need to make sure that I'm treating it with the respect it deserves. And you know, gone are the days where we should be able to just query a database and I can see all of the customer information. I mean, I think it should be encrypted. I think there should be a certain number of keys out there to decrypt the data, and I don't think those should be handed out to everybody. There's, even when I'm working in a system, if I have a number, like Tosh, let's say your customer ID number one, right? Uh,
Okay.
which we wouldn't use that because that's a number, and that's probably a bad idea. And you should probably get a little bit more random with your IDs. But if you're customer number one, do I really need to know all of your details, or do I just need to know customer one has these 10 orders, right?
Hmm.
And
Yeah, exactly.
there are ways to do development more securely and not be leaking information. If you do have access to production data and you're running locally, make sure that your machine and your network is protected. There's a lot of stuff that goes into that. Me personally, I run 3 routers. They're all segmented networks, and none of the other networks talk to any of the other networks. So I have into my house is the cable modem, and then I basically have 3 networks in my house: one for the kids, one for non-business, and one for my business.
Hmm.
And they're all separated. They,
Hmm.
they don't talk to each other. None of those machines are connected. And so if one of my family PCs or the kids' PCs get corrupted, then it doesn't have a way to filter out and compromise some of my other machines. I don't anymore, but I have had sensitive information stored on my machine, and you need to take physical and virtual care of making sure the access to that is as getting into that is as hard as possible. And so
Yeah.
take understanding basic network security, understanding protecting your machines, change your passwords fairly often. I know sometimes I'm guilty of forgetting to do that, but you need to be rotating your passwords, and then they need to be complex things. One of the patterns that I've really been liking lately as far as password goes is 2 words and a number. Um, like young yellow 387. For some reason, all the password cracking software, the ones that do the brute force dictionary attacks, they have a very hard time cracking those. Like, it takes forever.
Interesting.
So and it's just 2 words and a number, right?
Yeah.
So and you'll see that a lot on when you get a new like you get a new cable modem from your company, or you
Oh
get a
yeah.
new modem from your cable company, and you look on the bottom and have a password young trombone
Yeah.
318. And you'll be like, wow. And then you think, oh, that password's got to be easy to crack, but it is not. And so that's a good combination with easy to remember. A lot of browsers will auto generate a password for you. My one downside of those is those are usually not the easiest thing to keep in your head. I really don't
Yeah.
like writing down passwords. Everyone does it, even people who say they don't,
Yep.
as we all have to access a lot of different systems.
Yep.
If you are writing down passwords, make sure the application you're storing those in is able to be able to store excuse me, those notes or those pages correctly, or sorry, encrypted. And so that you basically get password prompted before you have to go in there. So just be careful about the information on your machine. Make sure you're protecting your network the same way that you protect your house, and make sure that when you're looking at your code, you're kind of coding with at least a little bit of security in mind on what you can do there.
Yeah, I totally agree. And I think it's very important that if you are feeling like maybe something in your systems might not be as secure as you wish it would, or you would like some ideas on how to have better security for your business or even for your personal, uh, like computers and stuff, because we all have them now. Like everyone needs a computer and a phone and all of that nowadays. Please feel free to either schedule a free consultation with us at our website, www.atmosoft.com. We would love to talk to you to help you come up with a plan to better secure yourself, and then also just get talking about maybe how we can help your business avoid future data breaches too, if that's something you are struggling with.
Code audits are a great idea.
Oh, yes.
That was one thing in my notes, and when you said that, it just kind of reminded me that have someone else, like even if it's not us, just maybe have someone else come in and review your code.
Yeah.
And look at it from a security standpoint. They can look at it from an architecture standpoint, but just somebody third party that's not directly involved in the application can shed a lot of light on, hey, this looks really good, but this particular function here, you're taking in these inputs directly from the web page. You're not doing any sanitation. You're not checking to see if the values or the variables are out of scope, and you could get a script attack here, or you could, your JavaScript right here, may present you a security vulnerability that someone that can take care of. So it's good to get those audits occasionally and have someone else come in and take a look, and just to make sure you're kind of up to par, and your code's doing what it needs to do, and you're not exposing yourself to any undue risk.
Yeah, it's better to know before something bad happens.
Yeah. I agree with you right there too, because when the bad thing happens, it can get, and then trying to figure out what happened,
Yeah.
and you're in the middle of the situation where you've had the breach, and you're trying to kind of shore up and fix the wall structures, and get your empire kind of reprotected, and make sure you don't have that is a time consuming and expensive process. And sometimes if you don't get to it quickly, I mean, as the hours progress through that situation, you're having more and more exposure till you can plug that gap, and not being able to say like, oh, I know it's the code, or I know it's the server, or something like that can cost you a lot of valuable time.
Yeah, it's definitely good to have as a preventative measure
Yeah.
before something bad happens. But
Agreed.
anyways, that's a great note to end on. Thank you, Bill, for your insights. And to our listeners, thank you for joining us on Atmosoft Tech Talk. We'll be back with more coding tips and strategies in our next episode. See you guys tomorrow.
Bye, guys.
Bye.